Picture the wheel in your hands, a straight 6 lanes of asphalt ahead of you, and nothing else. No coastline on the horizon, no hills, no islands, no distant ships to give you a sense of scale. Just water, flat, and pewter gray, wrapping the entire car in 360 degrees of open ocean, while the highway keeps you moving forward at a steady 100 kilometers an hour like nothing about this is unusual. 20 minutes of this, and your brain starts quietly insisting that something has gone wrong, even though the lane markings are perfect and the ride is smooth as glass. Then you feel it before you consciously see it. The road tips forward, just slightly, the way a diving board leans before somebody jumps. The horizon climbs up your windshield instead of sitting where it should. And the ocean that has been calmly keeping pace beside you for the last 20 minutes starts rising with it, closing in from both sides. Your stomach understands what's happening a full second before your mind catches up. This road is not going to a bridge, and it is not going to a ferry terminal. It is going into the sea. Straight down through a black concrete mouth cut into an island that was open water 20 years ago. And it keeps descending underneath the actual seabed for roughly 4 miles. Somewhere above your roof while you drive through that darkness, container ships stacked as tall as apartment buildings are gliding overhead on their way out of one of the busiest ports alive, and not one person on any of them has the faintest idea you exist down there. You've just driven onto the Hong Kong-Zhuhai-Macau Bridge, 55 kilometers, about 34 miles of highway thrown across open sea, home to the longest sea crossing and the longest immersed underwater road tunnel human beings have ever built. To make it happen, engineers had to manufacture 2 entire islands from nothing in the open ocean inside a typhoon corridor, purely so the road would have somewhere to dive. When the blueprints first went public, engineers in the US and Europe stared at them and asked the exact question probably forming in your head right now. Why on earth build it like this? The honest answer is that nobody handed them a choice. And the reason they had none of one is one of the strangest engineering puzzles of this entire century. Before we go under, tell me where you're watching this from and what time it is right there, right now. Drop your city and your local clock in the comments. Now let's find out why this road had no option but to drown itself. You can't understand this crossing without understanding the water underneath it. The Pearl River Delta is the densest concentration of manufacturing on the entire planet. Guangzhou, Shenzhen, Dongguan, Foshan, Zhuhai, Macau, Hong Kong. Tens of millions of people wrapped around one estuary, with practically everything those factories build eventually needing to leave by water. That means the channel running through the heart of the delta, a stretch called the Lingding-Yang Channel, carries some of the heaviest ship traffic anywhere on Earth. More than 4,000 vessels pass through it daily, not monthly, daily. Container ships, bulk carriers, tankers, ferries, fishing boats, an unbroken river of steel hulls moving around the clock every day of the year without pause. Here's the actual problem buried inside that traffic. Hong Kong sits on the eastern edge of that estuary. Zhuhai and Macau sit on the western edge, roughly 40 kilometers away across open water. For decades, the only way across was a ferry, or a long truck route curling around the top of the delta through Guangzhou, 3 hours minimum, worse in traffic. So, obviously, build a bridge. Engineers tried exactly that and hit a wall almost immediately. Letting those cargo ships pass safely underneath meant the bridge over the main channel needed serious height, a tower complex punching hundreds of meters into the sky, standing in open water, tall enough to let a fully loaded post-Panamax vessel slide beneath the roadway untouched. That's constraint 1. Constraint 2 sits directly overhead, the final approach corridor for Hong Kong International Airport, built on Cheklap Kok Island at the estuary's eastern edge. That stretch of airspace over the Lingding-Yang Channel sits inside the airport's flight height restriction zone, with aircraft descending through it continuously, which means there's a fixed, non-negotiable ceiling on how tall anything down here is allowed to reach. Sit with that pairing for a moment, because it's the whole riddle in 2 sentences. The ships beneath demand serious height. The planes above forbid it. Nowhere on the number line do those two requirements overlap. On paper, there is no version of a bridge that satisfies both. The problem, as written, cannot be solved. Add a third constraint almost nobody mentions when they talk about this crossing. That same estuary is home to a protected population of Chinese white dolphins. The usual way of building artificial land dumping and dredging until a mound breaks the surface would have ripped straight through their habitat, filling the water with silt plumes and driving the animals out of a stretch of sea they'd lived in for generations. So stack it up. An impossible height requirement, 4,000 ships a day, typhoon season arriving like clockwork every summer, and now a mandate to disturb the seabed as little as physically possible while building 55 kilometers of crossing through it. Most teams would have handed the brief back. Instead, somebody looked at the map and made a decision that sounds unhinged until you actually follow the logic. Partway across, the road would simply stop being a bridge. It would sink into a tunnel. Then, roughly 4 miles later, it would climb back out and become a bridge again. Every option above the waterline had already been closed off. Down was the only word left on the table. I want to be precise here, because plenty of channels oversell this next part, and you deserve the accurate version. China did not invent switching between bridge and tunnel mid-crossing. Not remotely. The United States got there first. In 1964, Virginia opened the Chesapeake Bay Bridge Tunnel, roughly 28 kilometers that dips into 2 separate tunnels, so naval and commercial traffic can pass overhead. Genuinely remarkable engineering for its era, built more than 60 years before this one. Europe did it too. In the year 2000, Denmark and Sweden opened the Øresund link, running as a bridge, crossing an artificial island, and finishing as a tunnel into Copenhagen, roughly 16 kilometers. Elegant enough that it became the reference project every future bridge tunnel team on the planet studied closely for the next 2 decades. So the idea already existed. The West had already proven the concept worked. Here's what actually changed. The Øresund link runs 16 kilometers. The Chesapeake crossing runs 28. The Hong Kong-Zhuhai-Macau bridge runs 55 in deeper water, inside an active typhoon zone, inside a seismically live region, over a bed of soft marine mud, directly beneath a functioning international airport's approach path, through the single busiest shipping lane on the planet, next to a protected marine sanctuary. This isn't a different idea from Chesapeake or Øresund. It's the identical idea, dragged out to a scale where every old method quietly stops working and somebody is forced to invent a new one. That, more than almost anything else, is the real story of Chinese infrastructure this century, once you strip away the theater. Rarely a brand new concept. Almost always a known one, pushed until scale itself becomes the actual problem to solve. Which brings us to the part where they had to invent ground that had never existed. Here's something that sounds obvious and isn't. A highway cannot simply dive off the end of a bridge into open water. Somewhere, the descent needs solid footing to launch from something to anchor the tunnel mouth, carry the ventilation shafts, house the emergency systems, the drainage, the fire suppression, the monitoring gear. On a normal tunnel, the shoreline does that job automatically. Here, there was no shoreline. Just 40 meters of open water sitting over soft mud. So before a single tunnel segment could go anywhere, engineers had to manufacture 2 islands out of nothing, one at each end of the tunnel, each one roughly 100,000 square meters of brand new land, call it 25 acres apiece, conjured straight out of the sea. The traditional route is dumping rock and sand until a mound breaks the surface. It works, but it's slow, and it moves enormous volumes of seabed material, the exact thing the dolphin sanctuary made off limits. So the engineers flipped the sequence entirely. And this is the part that earns the word extraordinary without qualification. They built the island walls first. 120 massive steel cylinders were fabricated onshore, each one 22 meters across, wider than a 4-lane road standing on end, the heaviest of them tipping the scale at roughly 513 tons. Each cylinder was floated to the site, held dead upright above the water, and then driven, not lowered, straight down into the seabed, punching through soft marine mud to depths of up to 33 meters, using 8 vibratory hammers firing in perfect sequence. Hold that image for a second. A steel tube, the width of a highway, taller than a 20-story building, hammered into the ocean floor like a fence post. Then a second one. Then a third. 120 times. Arranged into 2 enormous rings. Once each ring closed, it formed a watertight wall, and crews pumped the interior full and let it settle. Where there had only been open ocean, there was suddenly dry, stable ground with a perimeter tough enough to shrug off typhoon swells without eroding. 2 islands, built in months instead of years, without the large-scale dredging that would have wrecked the Dolphins' home. For scale, Boston's Big Dig, America's most famous urban megaproject, took roughly 15 years and around $15 billion to bury a highway under a city that already existed on solid ground, with a real shoreline to build from. This project had to manufacture the ground first, inside a live shipping lane, inside a monsoon zone, before the actual tunnel work could even begin. And the tunnel is where the difficulty stops being clever and starts being genuinely brutal. There are 2 ways to build underwater. The first is boring, a rotating cutting head the size of a house, grinding horizontally through solid rock beneath the seabed. That's how the Channel Tunnel between Britain and France got built. 38 kilometers of chalk marl drilled from both coasts at once. 6 years of work and a genuine marvel of engineering. But boring needs competent rock to chew through, and the Pearl River estuary doesn't have any near the surface, just soft, saturated sediment all the way down. Grinding through that, at this depth, at this scale, was never going to work. So they used the second method, the immersed tube, which is exactly what it sounds like, and exactly why it's hard to believe the first time you hear it explained. You don't tunnel under the sea at all. You build the tunnel on land in enormous sealed sections inside a dry dock. You float each section out into open ocean and sink it, one at a time, into a trench already carved into the seabed. You connect the sections underwater. You bury the whole assembly. Nobody is digging a tunnel. Somebody is assembling one on the ocean floor out of prefabricated pieces the size of ships. The scale of those pieces is where this stops sounding remotely reasonable. The full tunnel runs 6.7 kilometers, with roughly 5,664 meters of that sitting immersed directly on the seabed, built from 33 separate tunnel elements plus 1 final closure joint. Each element ran around 180 meters, longer than a Boeing 747.5 laid nose to tail, each one carrying a full pair of 3-lane carriageways side by side, plus emergency escape passages running the length of it. Each individual element weighed somewhere between 76,000 and 80,000 tons. Let that number actually sit with you. A single section of this tunnel weighs roughly as much as a Nimitz-class aircraft carrier, and they built 33 of them, back to back. Every section had to be sealed watertight on land, floated into open ocean, towed into position by tugs, and then flooded in a tightly controlled sequence, so it sank at a precisely managed rate into a trench prepared roughly 40 meters below the surface. Here's the detail engineers still bring up unprompted, years later. Each piece had to land within centimeters of its intended spot because a section that doesn't seat correctly against its neighbor means a joint that won't seal, and a joint that fails to seal at that depth is a catastrophic flood inside a structure meant to eventually carry thousands of cars a day. Now factor in what conditions they were actually working in. At its deepest point, the tunnel sits around 44 meters below sea level, with installation depths past 40 meters, in water thick enough with river silt that visibility all but disappeared. Divers and positioning crews could barely see the structure they were guiding into place. They were parking something the weight of an aircraft carrier, in near total darkness, in a live current, inside an active shipping lane, to a tolerance measured in centimeters 33 separate times, with no second attempt available on any single one of them. The final closure joint, the last piece that sealed the entire structure into one continuous tunnel, was completed in 2017, and by every account, it stands as the single most nerve-wracking operation of the whole decade-long build. There was no do-over waiting in reserve. What came out the other side is the longest immersed road tunnel on the planet, and the only deeply buried immersed tunnel of its exact kind anywhere on Earth. Step back now and take in the whole crossing at once, because the pieces are only half of what makes this remarkable. The entire system runs 55 kilometers, about 34 miles. The main offshore stretch alone measures 29.6 kilometers, split between 22.9 kilometers of elevated viaduct and 6.7 kilometers of tunnel, with 3 separate cable-stayed bridge sections carrying the road above the channels where ships still cross on the surface. The steel adds up to roughly 420,000 tons of structural plate, enough to build 60 Eiffel Towers, not 6, 60 plus, around 330,000 tons of reinforcing bar, and close to 1 million tons of concrete. The bill runs roughly 120 billion renminbi for the link itself, with total project costs, including connecting roads and border facilities, landing considerably higher depending on what gets counted. Construction broke ground in December of 2009. Main works wrapped in July of 2017. It opened to traffic on the 24th of October, 2018, nearly a full decade start to finish. And the single detail I find most striking of all, the whole thing was engineered for a service life of 120 years. 120 years in saltwater, inside a typhoon corridor, in a seismically restless region. Most major sea crossings worldwide are built to a 100-year standard, and no shortage of American bridges from the 1960s already need replacing after only 50 or 60. This one was specified to still be standing and still carrying traffic well into the 22nd century. None of us will live to check whether it actually gets there, but that was the literal brief handed to the engineers on day one. Now, here's my favorite fact about this entire crossing, and it has nothing to do with tonnage. In Hong Kong, traffic drives on the left, a holdover from British colonial rule that never changed after the 1997 handover. In mainland China, traffic drives on the right, which means a road connecting Hong Kong to Zhuhai runs headfirst into a problem no amount of steel can fix on its own. Somewhere along those 55 kilometers, every vehicle has to physically switch sides of the road, mid-journey, at speed. There's no gentle way to fade into that. You can't just repaint the lines. So at the boundary crossing facilities, traffic gets routed through a purpose-built interchange that lifts one direction up and over the other and sets it back down on the opposite side, a concrete knot engineered for one job only: flipping an entire nation's driving convention halfway across a bridge. There's more folded into this than steel. Hong Kong and Macau run as special administrative regions with their own immigration, their own currencies, their own vehicle licensing, entirely separate from the mainland. A private car can't simply drive from Hong Kong to Zhuhai the way you'd cross a state line. You need specific cross-boundary permits, and most people making the trip take one of the shuttle buses running continuously between the 3 boundary facilities instead, which means this bridge isn't only the longest sea crossing alive today. It's a piece of concrete that had to physically encode a political arrangement into its own structure. One country, and in the middle of the ocean, 3 separate sets of traffic law running side by side. I genuinely don't know of another structure on Earth built to do that. So after a decade, after 2 manufactured islands and a buried tunnel and 60 Eiffel Towers worth of steel, what did any of it actually change? The headline figure is simple. The trip between Hong Kong and Zhuhai used to run roughly 3 hours by road the long way, or a multi-hour ferry that stopped running the moment weather turned. Now it runs 40 to 50 minutes, rain or shine. That matters more than it sounds like it should. The western side of the delta had historically lagged behind the east, cut off from Hong Kong's port and airport by 40 kilometers of open water. This crossing was built explicitly to fold that western side into the same economic zone as the east, the region now marketed globally as the Greater Bay Area. I'll give you the criticism too, because it's real, it's documented, and a video that skipped it wouldn't deserve your time. Traffic volumes in the years right after opening landed well under the original forecasts. Critics have pointed out that the crossing reads as much like a political statement as an economic one, a physical tie in steel and concrete binding Hong Kong and Macau more tightly to the mainland. There are also documented ongoing concerns about the white dolphin population, despite every mitigation measure the engineers built in. None of that is invented or exaggerated, and it belongs sitting right next to the engineering story, not swept underneath it. But engineering and politics are answering different questions. Whatever conclusion you land on about why this got built, what actually got built doesn't move. 2 islands, hammered into the seafloor from 120 steel cylinders, 33 tunnel sections, each the weight of an aircraft carrier, parked blind on a seabed 40 meters down, with zero margin for a second attempt on any of them. 55 kilometers of highway across open sea, threaded directly beneath an international airport's approach path and directly under a shipping lane moving 4,000 vessels a day. That happened. It's sitting in the water right now, and you could drive it today. So go back to where we started. You're on a 6-lane highway with no land anywhere in sight, just open ocean and a ribbon of concrete, and the road ahead has just begun tipping downward. Except now you understand exactly what you're looking at. You know the road is diving because it was never allowed to climb the ships below, demanded a bridge too tall to legally exist, and the planes above forbade it outright, and down was the only word left on the table. You know the island you're about to enter didn't exist 20 years ago, and that it's held together right now by a ring of steel cylinders driven 33 meters into the mud beneath your tires. You know the 4 miles of tunnel waiting ahead of you were built on dry land, floated out to sea in pieces, and sunk into place in near total darkness, one section at a time, 33 times, by people who each got exactly one shot at getting it right. And you know that somewhere above your roof, right now, container ships the size of city blocks are gliding overhead, hauling the output of the largest manufacturing region on the planet out into the world, without the faintest idea you're underneath them. That's the Hong Kong-Zhuhai-Macau Bridge, the longest sea crossing ever attempted, and the only highway on Earth that solved an unsolvable problem by simply refusing to stay above the water. Tell me honestly in the comments, 55 kilometers of open sea, 4 miles of it beneath the seabed, are you driving that road or are you taking the ferry?